what was the evolution in this technology. Then we saw how the vacuum tubes were eventually replaced by the transistors, how the concept of integrated ICs came into picture, and then in 1965 Moore gave an important law, and then in 1975 it was established as Moore's law. Then in 1971 Intel launched its first microprocessor, which was 4-bit microprocessor 4004, and then microcontroller was invented, and so on. And then we saw the various differences between the microprocessors and microcontrollers, how actually microcontroller is used in everyday applications. So that was just to give you an idea about what a microcontroller is basically. So today we are going to talk of a more popular microcontroller, because there are lots of microcontrollers in the market, but the most popular one is 8051. In fact, after Intel, many other companies like Philips and Fairchild Semiconductors, Zilog, etc., they launched their own 8051 versions of microcontrollers. So this is in fact the most popular one, and we are going to study the main architecture, the basic block diagram, and assembly language program of this microcontroller today. So as you can see from this diagram, so this is the basic block diagram of the 8051, which was launched by Intel in 1981. Now what happened was that though all other companies also launched their own versions of this microcontroller, but Intel gave the copyrights with one condition, that the basic architecture should always remain the same. So that is why in all the controllers the basic block diagram will be like this, if you will see. And as you can see from here, there is one central processing unit which performs all the computing tasks, and then we have one on-chip oscillator. I'm going to talk more about this. And then we have bus control signals. There are 4 input-output ports. There is one serial port. There are 2 timers, counters, on-chip RAM, on-chip ROM. As we have seen yesterday, the main difference between a microprocessor and microcontroller is that all these things are there in one chip itself. And then there is an interrupt control itself. So if we see the main salient features of 8051, which at least everyone should basically know about 8051, is that it has got an on-chip ROM of 4 kilobytes. This is limited memory it has, the basic 8051 I'm talking of, and it has got 128 bytes of RAM. There are 2 timers, timer 0 and timer 1. These 2 timers are used for timing and counting purpose basically, because in most of the control applications, one of the major applications of microcontroller is in the control field. वहाँ पे हमें time delay देना, we have, that is one thing which all of you must be aware of. तो उसमें ये timers जो हैं वो बहुत important role play करते हैं. And then in all the counting events, whenever, for example, if you devise, अगर आप एक project बनाते हैं जिसमें आप एक automatic car parking कर रहे हैं, जिसमें you have to count that how many number of cars are coming, and then accordingly you have to shut on and off the gate. In that case, you have to, what you will need is the application of the counting part of the microcontroller. So these timers will be then used as counters. Or one more application we can think of is that in this hall, if we say that yes, limited 100 number of people only should be there. After 100 people have come, nobody should be allowed the entry. So in that case also, what you can do is the microcontroller will do the counting purpose depending upon how many people are coming inside. So these timers are used in such cases there. Then there are 32 input-output pins. Now, yesterday, when I was talking of microprocessor, then I told you that in order to real-world interface the microprocessor with real world, we need a chip. Which IC was that? 8255 programmable peripheral interface, because it does not have any input-output ports of its own. Whereas microcontroller has got its own input-output pins, so it does not require those chips externally to be connected. So there are 32 input-output pins. Basically, there are 4 ports. इसमें 4 ports रहते हैं. Port 0, port 1, port 2 and port 3. And all these ports are 8-bit. 8-bit है तो automatically 32 आपकी input-output pins हो जाएंगी. I will discuss this more when we'll see the bin diagram of 8051. Then for serial data communication. Serial data communication के लिए इसके पास एक serial port रहता है, and the interfacing of serial port with 8051 is another an important topic. which I'm going to tell you people later on, because in this course it will not be possible to discuss all these things. Microcontroller actually is a very vast field. So in these 5 days, what I have tried is to give you at least basic glimpse of what a controller is, what are the main features which you should know in order to work on microcontroller, and how to write simple programs, and then actually how to implement those programs in the real time. But if we talk of all these interfacings, real world interfacings, timers, counters interfacing, serial port interfacing, this is a very vast field which requires a lot of time. So for Miami students, I'm going to tell you these timer interfacing and serial port interfacing later on in the semester. And then it has got 6 interrupt sources, and there is one internal clock oscillator. This is very important. जो clock oscillator है, it basically generates the pulses which are required for the proper operation of 8051. ठीक है? अब जो पीछे वाले लोग हैं ना, आप लोग आगे आ जाइए. Those who are sitting, आप लोग आगे बैठिए. So this internal clock oscillator is very important. How? See, we all need heartbeat for our life. ठीक है ना? If there is no heartbeat, no life. Similarly, for the microcontroller, in order to work, it needs some pulses, and it has got internal clock oscillator. इसमें एक internal circuitry रहती है जो कि ये clock pulse को generate करती है, but still आपको ये clock pulses को generate करने के लिए you require to externally connect a quartz crystal. I will tell you. Will it be possible to use the board? Oh, कोई बात नहीं, मतलब मैं बाद में यूज कर सकती हूँ. Okay. So I'll be telling you because this is very important. Internal clock oscillator is very important. And then there are general purpose registers. So when we talk of registers, general purpose registers, for those who have worked on microprocessors itself, so can you tell me what are the main functions of registers? First, I would like to come to the centers. Anyone from the center, can you tell me what are general purpose registers? Yes, our participants. What are general purpose registers? Rameshwaram Institute?
Yes.
General purpose register.
Can anyone tell me what are general purpose registers?
Yeah.
Operates addition, subtraction, and store the result of these operations.
Can you repeat, sir?
It operates addition, subtraction, and stores the result of these addition and subtraction in the register are called GPRS.
Very good. Yes. Any other center? ये कौन सा सेंटर है? Asian Institute. Any answer for the general purpose register? See, general purpose registers, whether it is a microprocessor or a microcontroller, these are used for the temporary storage of the data. It may be any operation. Like one response I got was that for addition and subtraction, that is one type of operation, but it can be any operation. The final result, it has to be stored somewhere. So during the execution of the program, although the final result it is stored in the memory, but during the execution of the program, we need to temporarily store the data. In that case, these general purpose registers are used. Okay, and these general purpose registers are basically, if you have studied microprocessors, you must be remembering it is A, B, and then C, D, H, L. But in case of microcontroller 8051, it is R0 to R7. These are 8-bit. These are basically all 8-bit registers, because 8051 is an 8-bit microcontroller. So if I say that 8051 is an 8-bit microcontroller, what do you mean by that? हमने कल भी इसके बारे में डिस्कस किया था. एक तो यही बात है जो we discussed it yesterday also, that whenever we say that a controller or a processor is 8-bit in size, that means the size of its data bus is 8-bit. Another thing is that its internal registers, they are also of 8-bit in size. तो इसके जो भी जितने भी registers हैं, जैसे R0 to R7, all of them are 8-bit in size. If I talk of 8051 microcontroller, or similarly 8085 microprocessor, which you have studied in your BTech also. So 8086 microprocessor has got 16-bit registers. उसमें XC, AX, BX का concept आ जाता था. But in this case, all these general purpose registers are 8-bit in size. Then there are special function registers in case of 8051. Special function registers जो होते हैं, they are like accumulator, B, then all these ports P0 to P3. इसके अलावा there are some timers, there are some registers which are specifically used for timing operations, serial port interfacing, and then we have DHL, जो आपका उसके लिए high and low timers के लिए. So all these are special function registers. So these are the main salient features of 8051 microcontroller, which at least you should be knowing. Now coming to the memory type. Memory type, because these are all the things which distinguish one microcontroller from the other. जैसा कि हमने अभी basic block diagram देखा था, which is there in all the controllers. But what makes one controller different from the others? There are some features. One of the feature is the type of memory it has. Memory is very important. Now one type of memory is known as one-time programmable. One-time programmable का मतलब हो गया कि once you have written the program, you cannot make any changes to it. Okay? But while you are developing your product, you will not be using this one-time programmable. आप ऐसा तो नहीं करेंगे, because you need to debug your program and then you have to rewrite your program. So one-time programmable memory जिन controllers में है, हम उनको जब final product हमने बनाना है, तब हम वो वाला controller use करेंगे. Once we are sure that the program which we have written is okay, because one-time programmable microcontrollers are very cheap also. So during the execution of the program, we need a type of memory which we can erase and we can rewrite. ठीक है? उसमें एक type of memory जो होती है, that is UV EPROM. Now what is meant by UV EPROM? UV EPROM, yes, it is ultraviolet erasable programmable read-only memory. What is meant by this? कि yes, आप कैसे करते हो? Erase तो कर सकते हो, because EPROM का मतलब ही यही है, erasable programmable read-only memory. But erase करने का method क्या है? Basically इस तरह के microcontrollers के ऊपर एक window लगी होती है, quartz window. What you do is that you आप उसको expose करते हो, you expose it to the UV rays and it gets erased, and then you rewrite your program. And one example of this is 8751 microcontroller. जहां पे भी 877 की जो सीरीज है, इसका मतलब उसकी जो मेमोरी टाइप है, दैट इज UV EPROM. बट इट हैड गॉट वन डिसएडवांटेज. सी, जब आप, एक तो ये चीज है कि whenever you want to erase it, you need to take out your controller from your board. You had to put it in your UV programmable board, जो आपका erasable वो programmer था. Then you had to wait for around 30 minutes. Immediately तो वो erase नहीं करता. It took around 30 minutes. You had to wait till that time. Then you again take it, put it back, and then test it. If there is some problems, the same process repeated. So this was a cumbersome kind of thing. And I guess around 12-13 years back, I had used this technology, but nobody uses. Mostly people don't use it anymore. So the another type of memory is in-system programmable, flash memory. In-system programmable में क्या होता है कि आप अपना जो इन सिस्टम, नाम से पता चल रहा है, इन सिस्टम मीन्स आपका जो कंट्रोलर है, इट विल रिमेन इन द सिस्टम इटसेल्फ. यू विल डायरेक्टली कनेक्ट विद योर पीसी और योर लैपटॉप. Within few seconds it will erase the older one and it will rewrite your program. So within few seconds you are able to rewrite and erase your old program. So one such type of microcontroller is 8089C51. 89, तो जो 89 वाली सीरीज रहेगी, that means उसकी type of memory जो है, that is flash memory. So these are some of the things which you should be knowing when you're working. Actually, अगर आप real world में काम करते हैं, then you should be knowing which type of memory you have to use. As I told you, there are thousands of controllers which are available in the market with so many features that one gets confused that how to choose a particular microcontroller. That is again a very important thing which you must be knowing, that how to choose a particular controller. See, there are various factors which you must keep in mind when you have to choose which kind of controller we have to use. The first one is the cost. As I discussed yesterday also, that cost plays a very vital role when you have to make a large number of products. Let's say आपको एक product बनाना है जिसका cost should be around 200 rupees. Okay, let's say I'm an industrialist. I require one product, let's say a toy which just jumps, and I come to Vimal and tell you that Vimal is an engineer, and I tell him, Vimal, give me one product based on microcontroller, but my which jumps like this, but my condition is that because I have to manufacture 1 lakh units of such products, the cost should be only till 400 rupees. This is my condition. So when I go, then Vimal says, oh, I am an engineer, I am a embedded engineer, I've worked on very high level microcontrollers which have got this feature, that feature, this fast speed, and it has got inbuilt A to D converter. I will use that particular microcontroller. Ma'am will become very happy that wow, you have used such a high level microcontroller. He goes to the market, purchases that. The cost itself of the controller is 2000 rupees. He makes the product, no doubt it works fine. So when I come to him next time, I ask him, Vimal, have you made the thing? He says, yes, see, it's ready. I say, okay, wow, it's very good. So what is the total cost? He says, see, the controller cost is 2000 rupees, keeping all other things, it will come out to be 4000. So imagine my state being an industrialist who has to make 1 lakh such kind of units. So such thing is not an intelligent thing. So you should very wisely choose the controller according to your application. So in this case, my main criteria for choosing the product was cost. Another thing is my application didn't require very high features. So I will choose a controller which will be suffice for my application. Limited memory hai, koi baat nahi. Speed ka bhi, it's not a very critical application. Yes, in applications like space, etc., where time is very important. In that case, I'll have to choose a controller which has got such high performances. Then there are other features also which distinguish the controllers is, one thing I forgot to tell you is that a microcontroller works on digital. As we discussed yesterday while discussing the programming, it works on digital, zeros or ones. But the real-time data in the world is in which form? It is an analog form. For example, I give you a project in which you have to control the temperature of this ETV studio. So you will use one temperature IC, let's say LM35DZ, to control, to firstly read the temperature of this ETV room, ETV studio. But that temperature is in which form? It is in analog form. So firstly, you require to convert it into the digital form. That is one of the first factor which you must do while you are working on a microcontroller. So you require an ADC. Now in some controllers, this ADC is not available on chip, but there are some controllers available in the market today which have got on chip A to D converter as well. Okay, so so such kind of features also distinguish one controller from the other. And then, as I told you, another factor which you must keep in mind while choosing a controller is the speed. As we discussed that in applications where the speed is very critical, for example, there is some process control going on wherein you have to control a conveyor at a particular speed only. If you don't make it that fast, your product may be damaged. So in such applications, you have to wisely choose the controller which has got such kind of speed. And also in applications which are very critical, for example, space, where in microseconds you have to take a decision. So in such cases also, you have to choose a controller accordingly. So these are all the memory types. Now before we go to other, I would like to tell you about that on-chip oscillator I was telling you of. On-chip oscillator basically a controller has got inbuilt oscillator circuit, but in order to generate those pulses, you have to, is it clear? There are two pins available on the in the pin diagram of the 8051, pin number 18 and pin number 19. These two pins are basically used for this on-chip oscillator. So pin number 19 is known as crystal 1 and this is crystal 2. And internally you have a circuit like this. Which basically generates. But at these two pins, you have to connect.
मैम थोड़ा सा लाउड है, थोड़ा सा माइक दूर होगा ना आपसे।
अच्छा मैं ना पहले फिर ड्रॉ कर लेती हूँ, मैं वहां आके बोलूँगी। So as you can see in this diagram, there is one internal circuitry which actually generates the oscillator, your pulses, and on pin number 18 and 19 externally you have to connect a quartz crystal. Now this quartz crystal should be of the same frequency on which you want to operate your microcontroller on. The range of frequencies on which the controller can work on is 4 megahertz to 30 megahertz. जो total range of frequencies है that is 4 megahertz to 30 megahertz. तो जितनी भी frequency पे आपने काम करवाना है that much of frequency quartz crystal you should be connecting here. As I told you that this range is between 4 megahertz to 30 megahertz. But actually so the frequency which you are seeing here, 11.0592 megahertz, this is the frequency on which the controller mostly works on. 11.0592 megahertz. You should be knowing this thing because आप जब तक right amount of crystal नहीं लगाएंगे, it will not generate the pulses rightly. Now what is the reason for थोड़ा अजीब सा figure है ना 11.0592 megahertz लग रहा है ना ऐसा थोड़ा सा, but what is the reason? Does anyone know why do we use 11.0592 megahertz? Yes, our centers. Can anyone tell? Does anyone have any idea why this 11.0592 megahertz is used? See, these all which things I'm telling you are the practical aspects when you actually work on the controller, which you must be aware of. Now, the reason is because at this particular frequency of quartz crystal, the microcontroller is best compatible with the IBM PCs. इसका जो baud rate compatibility है, वो best इस frequency पे आती है. Now, what is meant by baud rate compatibility? See, basically when we have to program our controller, how do we program it? हम करते तो PC के through है ना? तो PC के through जो इन दोनों के बीच जो when we do the serial communication, then we have to take into consideration the baud rate compatibility. How many number of bits are transferred per second? So at this particular frequency, the baud rate compatibility of controller with IBM PCs is the best. So that is why the the quartz crystal which we have to choose should be of 11.0592 megahertz. Now this is one difference between a microprocessor and a microcontroller. For those who have worked on 8085 microprocessor, you must be aware of that the internal circuitry of 8085 microprocessor is such that it internally divides the frequency by 2. Let's say आपने उसको 3 megahertz पे काम कराना, then you have to connect a crystal of 6 megahertz. तो वो internally उसको divide करती है 2 से. But in case of microcontroller, it is not so. जितनी frequency पे आपने उसको काम कराना है, the same amount of frequency you have to externally connect to it. ठीक है? Any doubts in this? Because this circuit is very important. This on-chip oscillator circuit. When you are practically designing your project or anything you're working microcontroller on.
जब अल्ट्रावायलेट रे को ग्राफ की क्वार्ट्ज फिट करते तो जो ग्रेज का कॉन्सेप्ट है वो इसी से यही से होता है।
नहीं नहीं, वो तो क्वार्ट्ज की विंडो है उसके ऊपर, दैट इज अ सेपरेट थिंग. क्वार्ट्ज का जो व्हाई वी take quartz window on that kind of controller is because you can also take a glass window in that case, but the glass window is opaque to the UV rays. So why we choose a quartz window in that case is because the quartz material is transparent to the UV, but that has got nothing to do with this. This is a crystal. This is a quartz crystal. Now the question is that why do we require these two capacitors, as you can see here. See, there are two capacitors here. The mostly values which are used are 33 picofarad. In case you don't get the value 33 picofarad in the market, आप इसको 22 picofarad भी ले सकते हैं. Now that is because the reason for choosing these two capacitors of 33 picofarads or 22 picofarads is because see, basically circuit क्या है, एक resonant circuit है. It is basically generating a resonant circuit. So if you do not connect these two capacitors, then it will resonate also at harmonic frequencies. So this basically filters out the harmonic frequencies. So that is why these two capacitors should also be used. These are ceramic capacitors which are used. Now coming to the memory, as I told you, on-chip memory. We are now discussing all the points, the salient features of 8051 one by one. So we have already discussed the on-chip oscillator. Now we come to the memory. Now, as we saw that 4 kilobytes of on-chip ROM is available for 8051, but it's not that you cannot externally connect any kind of memory to 8051. Yes, you can. There is a provision of externally connecting memory, whether it can be ROM or RAM also, and you can connect up to 64 kilobytes. 4 kilobytes, so इसके पास on-chip memory है, तो total of 64 kilobytes of memory can be connected to it. Now, you have any idea why we can connect it, or what basically decides? See, it is not our wish will कि हम कितनी भी memory इसमें लगाते रहेंगे, चाहे वो एक microprocessor है, चाहे वो एक microcontroller है. So what is the deciding factor? What is the deciding factors? Yes, our participants. What decides how much amount of memory should be attached to a microprocessor or a microcontroller? As we saw yesterday that in case of a microprocessor, you can externally connect a memory. Similarly, in case of microcontroller also, you can externally connect a memory. Now, the deciding factor is the address bus. There are two buses. One is the data bus, the other is the address bus. The data bus was responsible for the speed, जो हमने कल discuss भी किया था ना. I told you about the significance of the data bus. As the size of data bus keeps on increasing, your execution time reduces and the speed it increases. Now the address bus is vital because the amount of your memory which can be attached, which can be mapped by a controller or a processor, is decided by the address bus. Now how? The total amount of memory which you can map to a controller or a processor is basically 2 raised to power n, where n is the size of your address bus. Where n is the address bus. Now for our 8051 microcontroller, it is address bus size is 16 bit. Similarly for 8085 microprocessor also, 8 bit is the size of the data bus and 16 bit is the size of the address bus. So the total memory which can be mapped or which can be attached to it is 2 raised to power 16, which is 64 kilobytes. So that is why we say that a total आप इसके साथ external memory जो attach कर सकते हैं that can go up to 64 bytes. 64 kilobytes. Though on chip is 4 kilobytes, and this is ROM, and 128 bytes is RAM. So what I have written here is that your address bus decides the amount of memory. So that is like 2 raised to power n. In this case, the size of address bus is 16 bit in size. So that is 2 raised to power 16 is 64 kilobytes of memory. Whether it is ROM or RAM can be externally connected to this. And on chip is 4 kilobytes of ROM and 128 bytes of RAM. Now what decides that if external memory is to be interfaced or not? There is one pin on in the pin diagram of 8051, that is pin number 31. That pin is also very important. Now, see these things like I told you about 18 and 19 wherein you had the quad crystal attached, and now I'm telling you about pin number 31. These are some of the things you may make any application, whether it's a small, आप एक LED glow करवा रहे हैं माइक्रोकंट्रोलर के साथ, चाहे आप एक स्पेस का प्रोजेक्ट कोई भी बना रहे हैं, ये जो कुछ पॉइंट है ये आपको हर बेसिक जो कंट्रोलर की सर्किटरी में लगाने ही है. तो एक तो हमारा क्वार्ट्ज क्रिस्टल हो गया. देन ऑन पिन नंबर 31 देयर इज वन पिन व्हिच इज EA, एक्सटर्नल एक्सेस पिन. नाउ एक्सटर्नल एक्सेस पिन इज बेसिकली अ एक्टिव लो पिन. एक्टिव लो मतलब क्या होता है? व्हाट डू मीन बाय एक्टिव लो? हाँ, देखो हम जब माइक्रो कंट्रोलर की बात करते हैं तो इट बेसिकली डीसी पे काम करता है वो, एंड सप्लाई विच इज गिवन टू इट इज 5 volt DC. So that is the power supply which you connect to it on pin number 40. So that means because it talks of only digital, no, 0 or 1. So 1 in this case is if you connect it plus 5 volt, and 0 in this case is in case you connect it to ground. So this external access pin is an active low pin basically. What is meant by active low pin means it will be active or it will be working when it is connected to low, that is ground. So external access pin is very important pin. The significance of this pin is that if it is connected to ground, that means you have externally connected the memory. Always remember this point because you cannot leave this pin unconnected. आप इसको unconnected नहीं छोड़ सकते. Either you have to connect it to ground or you have to connect it to VCC. अगर आप external memory नहीं लगा रहे हो, that means आपने इसको active low नहीं करना है. Then in that case you will connect it to the VCC, but you will never leave it unconnected. These are some things you should be telling your students also when they are in their projects based on 8051. Okay, now because we are talking of external memory or on memory concept, now I back to on chip RAM, that is 128 bytes RAM. Now how is it allocated? On chip है वो allocated इस तरह से रहती है. We have total 128 bytes of RAM as I told you. Out of these, as you can see from here, this is 8051 RAM allocation. The centers is this clear? Is this diagram clear? Because on-chip RAM allocation is very important when you're working on a controller. See the total 128 bytes of on-chip RAM, as I told you, out of which there are total 32 kilobytes are kept aside for the register banks. Register banks के लिए there are 4 register banks, R0 to R7. So as you see from here, from this diagram, that out of 120 bytes, the first 32 kilobytes, they are reserved for register banks. There are 4 register banks: register bank 0, register bank 1, register bank 2, and register bank 3. Now, what are these register banks? If you remember general purpose registers, when I told, so general purpose registers कौन से थे हमारे? R0 to R7. So these contain these general purpose registers. So these contain your general purpose registers R0 to R7, and then next 16 kilobytes, they are reserved for bit addressable. Bit addressable is another very important feature of 8051 or controller, microcontroller, which makes it different from a microprocessor. How? See, when we're talking of bytes, 8 bits means 1 byte. All of you are aware of that. Microprocessor work on bytes. वो 8 bits के ऊपर at a time काम करेगा. But a microprocessor, a controller has got this advantage that it can work on a bit also. Single bit के ऊपर भी ये काम कर सकता है. One of the major application of microcontroller is in control applications. The control applications में ये bit addressability है, it's very important. In today's second class, when I'm telling you about programming, then I'll tell you about how bit addressability is done in case of 8051. So the bit addressable registers, they are reserved in this 16 kilobytes, and the next 80 kilobytes, they are scratch pad memory or general purpose memory. Now apart from this, there is another 128 kilobytes also. Sorry, I'm saying kilobytes. It is bytes. Sorry, it is not kilobytes. Because there are a total of 128 bytes. G. So it is bytes, not kilobytes. So another 128 bytes, they are also reserved or they are mapped for special function registers. जो हम special function registers की बात कर रहे थे ना, register accumulator, B, etc. So that memory is reserved for that also. I'll be discussing more about this, these general purpose registers and special function registers in my next class, which will be on programming the controller. Because programming के लिए आपको basically ये general purpose registers का concept जो है ये, it should be very clear. But for basic hardware part, you should be aware of that how this 128 bytes of RAM is allocated. As you can see that there are 4 register banks and all of them contain R0 to R7. So a question may arise in your mind that because R0 to R7 तो हर register bank में है, तो अगर हम एक register लिखते हैं, let's say R0, then which register bank or which particular memory address will it be am I talking of? So always remember that the default register bank is the register bank 0. Always remember this, that the default register bank is register bank 0. Now why have I allocated all these all this memory? See, whether it is your register, whether it is your special function registers, all of them have got memory addresses associated with that. Otherwise, how will the controller or the CPU inside the controller know where I have to go to? This is another very important concept, a basic general concept which you should know about the working of a controller or a microprocessor. Now I'll give you one general analogy about that. For example, I tell Aarti that Aarti, you have to go to my house and fetch me one parcel. Then what is the first question which Aarti is going to ask me? Ma'am, what is your address? If I don't give her my address, I'll say go and go to my home. I'll not tell you my address. She'll keep roaming in Chandigarh, not knowing where I have to go actually. Similarly, in the controller or a microprocessor, all the data or your instructions, they are stored in the memory. That is why we say data memory, which is your RAM, and program memory, that is your ROM. So all your data and your instructions are stored in your memory, and all these data and your instructions, they are stored at a particular memory location. So what happens is that initially through the address bus, आपकी address bus के through, it sends it the address, so it knows where I have to go. Then it goes to that particular location, and then through the data bus, it fetches that data. So you understand how the data bus and address bus operates? Now always remember that the data bus is it is bidirectional, because the data can be sent, it can be received also. आप किसी particular मतलब CPU जो इसके अंदर है माइक्रो कंट्रोलर के, वो किसी particular memory location पे डाटा सेंड भी कर सकता है and it will receive it also. But the address bus is always unidirectional, because एक बार उसने उसको पहुंचा, उसका काम सिर्फ ये है कि उस particular address पे पहुंचा दिया, उसके बाद उसका काम खत्म. So address bus is always unidirectional. Now, as I told you that this register bank 0, it is the default register bank, and which contains the R0 to R7. But it's not like you always have to be there only. आप इसको shift भी कर सकते हो. R0 से R7 आप दूसरे particular memory location का भी ले सकते हो. Register bank 2 का भी ले सकते हो, 3 का भी ले सकते हो. वो कैसे कर सकते हैं? That is through the program status word, which I'll tell you. Program status word. So these are the register banks and their RAM addresses. This is the register bank 0. This is register bank 0, and in this we have R0 to R7, and it has got address from 0 to 7. Similarly, register bank 1, register bank 2, and register bank 3. Now this is the program status word register or the flag register. Flag register, basically mostly people know it in the microprocessor. Microcontroller में हम इसको program status word register कहते हैं. Now what is the significance of this flag register? Status of the operation from the
address bus and the data whatever we have to transfer.
First चीज तो आपने ठीक बताई, tells the status of the operation from the accumulator. Now when we are talking of special function registers, general purpose registers we have already seen. These are R0 to R7, which are used for the temporary storage of the data. Now in the special function registers, a very important register is the accumulator. Now what is the function of accumulator? See, whenever you are doing any arithmetic or logical operation, your data result will be stored in the accumulator always. Suppose you are doing addition of two numbers, then your एक तो ये चीज है कि one of the number must be in accumulator, और दूसरा नंबर आप कोई और रजिस्टर यूज कर सकते हैं, and then the final result after the addition of these two numbers, it will also be stored in the accumulator itself. Now accumulator has got some status, ठीक है, accumulator के पास कुछ result आ गया. अब उस result को देखकर this flag register will be affected. How? As you can see here, it is basically an 8-bit register. जो flag register है वो आपका एक 8-bit register है, जिसमें आपका first bit जो है that is parity. Parity का मतलब क्या होता है? अच्छा, एक और चीज है, as you can see from here that program status word register जो आपका flag register है, इसको हम PSW बोलते हैं. तो आप इसकी एक एक बिट को भी एड्रेस कर रहे हो. See, PSW.0, PSW.1, PSW.2, ऐसे करके PSW.7. ऑब्वियसली 0 से शुरू हुआ इसलिए 7 तक जा रहा है. तो जो इसकी फर्स्ट बिट है दैट इज PSW.0. सो कौन सी है इसमें देख के बताइए? Parity. Now what is the significance of parity? Can you tell me? Error detection. Yes. आपका जो फाइनल रिजल्ट आया है, लेट्स से आपने दो नंबर्स ऐड किए, मैं अभी आपको एक एग्जांपल भी बताऊंगी इसका. लेट्स से आपने यू हैव एडेड टू नंबर्स. नाउ इन योर फाइनल रिजल्ट व्हाट इज द टोटल नंबर ऑफ वंस? that will affect your parity, the total number of ones, whether it is odd or whether it is even, that will affect your parity. Then the second PSW.1, it is user definable, we do not use it. And then we have PSW.2, which is an overflow flag. Overflow flag is the one you are telling of for error detection. ये हम जब प्रोग्रामिंग करेंगे तो थोड़ा सा डिटेल में इसके बारे में then I'll tell you. And then we have PSW.3 and PSW.4, RS0 and RS1. Now this is the register which is responsible for shifting of the register bank. As I told you ना, अभी जो हमने RAM allocation किया था उसमें की default register bank क्या है, 0 है. अगर आपने उसको shift करना है तो कैसे कर सकते हैं? Then these 2 bits of PSW will be used for shifting from one register bank to the other. In case both of them are 0, PSW.3 and PSW.4, which is RS0 and RS1, then register bank 0 is chosen. In case 0 1, register bank 1, 1 0 2, 1 1 3. ठीक है, तो अभी आप इतना याद रख लीजिए. कैसे करेंगे हम इनको सेट या रीसेट, वो भी प्रोग्रामिंग वाली क्लास में मैं आपको बताऊंगी. एंड जस्ट रिमाइंड मी ऑल्सो कि वी हैव टू डू द PSW.3 का कैसे हम कर सकते हैं. इन केस आई फॉरगेट जस्ट. हाँ जी, नहीं, इसमें 0 फ्लैग नहीं होता. अब वो माइक्रो प्रोसेसर में होता है. इन दिस केस देयर इज नो 0 फ्लैग. Then there is the PSW.6, which is auxiliary carry flag. Auxiliary carry flag basically क्या होता है कि अगर आपकी, because इसमें देखो it's an 8-bit microcontroller, so the size of its register is 8-bit in size. तो उसमें आपकी जो D3 से D4, see, this is one number, let's say this is the second number. Let's say you are adding these two numbers. So if there is a carry generated between D3 to D4, if there is a carry between D3 and D4, then your auxiliary carry will be 1. Otherwise, तो यहाँ पे अगर हम बात करते हैं ना सेट या रीसेट, तो सेट मीन्स इफ इट इज 1, so in case auxiliary carry is 0, then it is reset. In case it is 1, then it is set. Okay? तो अगर आपका D3 से D4 के बीच में कोई कैरी जनरेट हुआ है, then in that case your auxiliary carry will be set, otherwise it will be reset. And then the final one is your carry. अगर आपके रिजल्ट में D7 के बाद कोई कैरी जनरेट हुआ है तो ये आपका सेट हो जाएगा, otherwise it will be reset. Now what is the significance of all these things? हम क्यों कर रहे हैं? Why are we worried? हमें क्या है, होता रहे. Why should we be bothered about this status? Because इसमें एक jump operation रहता है. हम जब कंट्रोल ऑपरेशंस की बात करते हैं, in that case you have to take a decision. हमें एक डिसीजन लेना है. In case carry is generated, do this. In case auxiliary carry is generated, do this. So in such cases, we see the status of these flag registers. When I'll tell you about jump instructions, तो jump में एक conditional jump होता है. जो conditional jump है, that is done only after checking the status of all these flag registers or PSW, program status word register, or microcontroller. It's very important. Flag register is very important because normally कभी भी हमने decision लेना है, so decision will be taken after checking the status of this flag register. Next we come to switching register banks, as I've already discussed, that PSW.3 and PSW.4 is used for switching the registers. In case both are 0, register bank 0 will be selected, in case 1, and accordingly. These are the 8051 registers. I've already told you about them. R0 to R7. These are general purpose registers. Then there is accumulator, which is used to store the result of all arithmetic operations. Then there is B register. B register वैसा तो एक जनरल पर्पस रजिस्टर की तरह इसको यूज कर सकते हैं. जनरल पर्पस रजिस्टर in the sense that for the temporary storage of the data आप इसको यूज कर सकते हो. But always remember that this is mainly used in case of division and multiplication operations. डिवीजन और मल्टीप्लिकेशन ऑपरेशंस में आपका रजिस्टर बी जो है वो मेनली यूज होता है. दिस इज द पिन डायग्राम, वेरी इंपॉर्टेंट. पिन डायग्राम अगर हम हार्डवेयर की बात करते हैं कि जब तक आपको यू आर नॉट वेल वर्स्ड विद द पिन डायग्राम तब तक आपको हार्डवेयर के बारे में कुछ नहीं पता. So being an embedded engineer, when you're working on controller, when you're working on 8051, then you should be learning this by heart, I would say. You should be knowing pin number 9 पे आपको एकदम पता होना चाहिए reset है. Pin number 18, 19 पे आपको एकदम पता होना चाहिए crystal 1, 2 पे. When you are actually designing your hardware, because that is where you will be connecting all your circuitry, na? So there are many packages of in which these controllers come. One of them is PDIP. That is dual inline package. इसके अलावा और भी quad package वगैरह भी होते हैं. Then there is surface mounted package etc. ये जो quad ये जो अपना dual inline package है, in my next class Wednesday को I'll show you a controller also in which किस तरह से ये दिखता है controller basically. So as you can see from this pin diagram that it is basically a 40 pin microcontroller. ठीक है. पिन डायग्राम इज वेरी इंपॉर्टेंट. व्हेन आई से वेरी इंपॉर्टेंट डजंट मीन ओनली एग्जाम पॉइंट ऑफ व्यू कि यू शुड बी नो इंपॉर्टेंट मैम बोल रहे हैं मतलब एग्जाम में आएगा. नो, व्हाई आई एम सेइंग इट इज इंपॉर्टेंट इज बिकॉज व्हेन यू आर एक्चुअली वर्किंग ऑन माइक्रोकंट्रोलर देन दीज पिन्स आर द वंस which you will be basically working on. Your soldering, your program, आपका प्रोग्राम भी इस पे डिपेंड करेगा आपने किस पिन पे क्या कनेक्ट किया है. So as you can see that it is a 40 pin diagram. There are total of 40 pins. On one side we have pin number 1 to 20, the other side you have pin number 21 to 40. Now how to know कि pin number 1 कौन सी है and pin number 40 कौन सी है? So as you can see here there is a notch. ये आपको इस तरह का एक notch दिख रहा है. This one. So what you will do is you will keep your controller in front of you and you will see this notch. Then the pin on the left side of the notch is pin number 1. And on the right side of the notch is pin number 40. And as I told you that there are 4 ports, total 4 ports. Ports क्या है basically? Input output ports, which are used for the real world interfacing के लिए use होते हैं हमारे. So as you can see here, we have 4 ports. Port 0, port 1, port 2, and port 3. So this is port 0. This is port 1, this is port 2, and this is port 3. Pin number 1 से लेके pin number 8 तक you have port P1. Now as I was telling you about single bit addressability की मैंने बात की थी ना जब हमने RAM allocation किया था, then I was telling you about single bit addressability कि one of the main features of microcontroller is that it has got single bit addressability. One we saw in the case of PSW also, flag register के केस में भी we saw कि हम आप एक single pin को भी program कर सकते हैं. Similarly all your ports are also single bit addressable. If I say port 1, it is basically a 8 bit port है आपका, लेकिन आप इसके एक बिट को भी एड्रेस कर सकते हो. एंड दिस इज वेरी इंपॉर्टेंट व्हेन वी आर डूइंग द रियल वर्ल्ड इंटरफेसिंग. फॉर एग्जांपल, suppose I design one kind of project in which I have a door sensor. ठीक है. So उस door sensor में मैंने एक वो लगाया है बिट देखनी है कि in case डोर ओपन है तो मैं उसको इस तरह से कनेक्ट कर देती हूँ कि इन केस इट इज ओपन इट विल बी कनेक्टेड टू VCC और एल्स इट विल बी कनेक्टेड टू ग्राउंड. सो व्हेनेवर द डोर ओपन्स सो आई हैव टू साउंड अ बजर सो दैट आई कम टू नो दैट यस द डोर इज ओपन. सो उसमें क्या हो रहा है वो सिंगल बिट हमारी जो है हम उसको डिटेक्ट कर रहे हैं. डोर सेंसर को हमने एक पर्टिकुलर बिट पे लगाया, लेट्स से P1.0 बिट पे लगाया. सो आई विल बी कनेक्टेड ओनली दैट पर्टिकुलर बिट. मुझे टोटल पूरा का पूरा पोर्ट यूज करने की जरूरत नहीं है. So I'll be just checking the status of P1.0. In case it is high, साउंड अ बजर, और बजर भी मैं किसी एक पोर्ट पिन पे लगा दूंगी, उसका कनेक्शन करके अकॉर्डिंगली बजर जो है वो साउंड कर देंगे। हम प्रोग्रामिंग की डिटेल जब करेंगे तो एक्चुअली हम बजर को साउंड कैसे करेंगे या डिटेक्ट कैसे करेंगे आपको मैं बताऊंगी, बट अभी हम बात करें सिंगल बिट एड्रेसेबिलिटी की। तो जहां पर भी आपको एक सिंगल बिट को देखना है, लेट्स से आपका एक ऐसा ऑपरेशन है जहां पे हमने कुछ ऐसा वो बनाया है सर्किटरी जिसमें टेम्परेचर आप सेंस कर रहे हैं। सो इफ द टेम्परेचर इज हाई, इट बिकम्स मोर देन 100 डिग्री सेल्सियस, साउंड अ बजर। सो वो बिट आ रही है, कॉन्टिन्यूसली आ रही है, यू आर गोइंग मॉनिटरिंग इट। सो द मोमेंट इट बिकम्स हाई, that particular bit I'm talking of, you will sound the buzzer. So in such cases you will use a particular bit of port. Now when I say P1.0 to P1.7, so if I ask you that P1.5, what does it mean? See what we have. Abhi main I'm talking of just one port. Let's say P1.0 to P1.7. So this is basically first bit. So 0 represents the nth bit and this represents the port. So and similarly this is the 8th bit of port 1. So if I write P1.5, what does it mean? This is the 6th bit of, this is the port 1. Similarly P3.2, what does it mean? Third bit of, because हम 0 से शुरू कर रहे हैं इसलिए आप 8 ऐड करके third bit of port 0. ठीक है? So now come to this pin diagram. Now come to the pin diagram. As you can see, this is port P1 and this P0.0 to P0.7 is the port 0. So it is always like if you see the pin diagram, it is 0, 1, 2, 3. ऐसे याद रख लेना आप. Confused नहीं होना. You need not cram the things. Just remember when you have the pin diagram, it is 0, 1, 2 and 3. Now looking at this pin diagram, can you tell me the participants, are you able to see the pin diagram clearly?
Yes ma'am.
ओके नाउ अब आप मुझे बता सकते हैं कि जो हमारे चारों पोर्ट्स हैं जिसमें राइट साइड पे हमारा पोर्ट 0 है, लेफ्ट साइड पे पोर्ट 1 है, देन नीचे राइट साइड पे पोर्ट 2 है एंड लेफ्ट साइड पे पोर्ट 3 है, इन सारे पोर्ट्स में आपको कुछ डिफरेंस लग रहा है कि एक पोर्ट कुछ अलग लग रहा है सबसे?
मैम
बताइए।
एक मैम सीक्वेंशियली 0 to 7 जा रहा है और एक एंटी इसमें जा रहा है मैम।
हाँ जी, सीक्वेंशियली क्या कह रहे हैं? एक्चुअली ये देखिए हमारे 4 पोर्ट्स हैं, पोर्ट 0, पोर्ट 1, पोर्ट 2 एंड पोर्ट 3। तो इस पिन डायग्राम को देख के आपको ऐसा कुछ डिफरेंस लग रहा है कि कोई एक पोर्ट दूसरों से अलग किसी फंक्शनैलिटी में या कुछ किसी चीज में आपको अलग लग रहा है? लेट मी आस्क द पार्टिसिपेंट्स फर्स्ट।
मैम अब विजिबल नहीं हो रहा।
विजिबल नहीं है?
नो मैम, एक्चुअली वो थोड़ा सा क्लैरिटी चाहिए, वो दिख नहीं रहा मैम।
मैं इससे ज्यादा तो मैग्नीफाई एक्चुअली उसी पे किया हुआ है ना, एक मिनट में देखती हूँ।
मैम एक्चुअली फॉगी दिख रहा है।
इससे ज्यादा मैग्नीफाई नहीं हो रहा। मैं आपको वैसे बता देती हूँ, देखिए ये जो है ना, बिकॉज आई एम, आपको वो पॉइंटर तो दिखाई दे रहा होगा ना इसका, विच आई एम मूविंग नाउ माउस का। नाउ दिस पोर्ट इज बेसिकली पोर्ट 1. So this port is basically port 1 and this port is basically this port is port 0 and this is port 1, this is port 2 and this is port 3. तो जो डिफरेंस जिसकी मैं आपसे बात कर रही हूँ, यस स्टूडेंट्स, यस, हाँ अच्छा ओके अच्छा, ये एक नया रिमार्केबल आपने मुझे बताया। ऑल्सो कीप दिस इन फ्यूचर। देखिए अगर हम फंक्शन की बात करेंगे, दैट इज व्हाट आई वांट टू आस्क फ्रॉम यू। अगर हम फंक्शंस की बात करते हैं ना, तो देखिए सारे पोर्ट्स एक्सेप्ट दिस पोर्ट 1 हैव गॉट डुअल फंक्शंस। हमारा ये जो पोर्ट 0 है, ये वाला, इसमें पोर्ट 0.0 से लेके 0.7 तो है ही है, लेकिन जो ब्रैकेट में लिखा हुआ है ना AD0 to AD7, दिस इज इट्स डुअल फंक्शन। व्हाट इज इट, आई विल टेल यू। अभी मैं एक एक पोर्ट एक्सप्लेन करूंगी। सिमिलरली पोर्ट 2 जो है वो आपका पोर्ट P2.0 से लेके P2.7 जो है, उसके भी ब्रैकेट में आपका ये A8 से A15 लगा। आई विल ड्रॉ दिस पिन डायग्राम हियर इन केस आपको ये क्लियर नहीं दिखाई दे रहा है एक्सप्लेन करते वक्त। सिमिलरली पोर्ट 3 जो है आपका 3.0 से 3.7 के ब्रैकेट में देखिए RxD, TxD, इंटरप्ट, T0, T1। सिर्फ पोर्ट 1 एक ऐसा पोर्ट है जिसमें डेडिकेटेड इनपुट आउटपुट ऑपरेशन है, इसका कोई डुअल फंक्शन नहीं है। So this is one difference. So if you are asked ever that out of all the 4 ports, which port has got the dedicated input output function, so now you can tell port 1. ठीक है? Okay. Now coming back to the pin diagram, from pin number 1 to pin number 8 we have port 1, which is the dedicated input output port. So this is the port which we normally prefer also. हमने अगर कोई एक छोटी सी एप्लीकेशन करनी है जिसमें हम कोई भी पोर्ट यूज करना चाहते हैं, तो हम जो है वो सबसे पहले पोर्ट 1 ही यूज करेंगे। देन ऑन पिन नंबर 9 वी हैव द रीसेट सर्किट, वेरी इंपॉर्टेंट, रीसेट सर्किट। I'll explain. Firstly, I'll draw it here and then I'll explain. Now this is one type of reset circuit in which we have one capacitor here and we have one resistor here. So what is meant by reset circuit? Now reset circuit का मतलब ये होता है कि whenever we want to reset the controller, so all its internal registers value becomes 0. इसके internally सारे registers की value जो है वो 0 हो जाती है। So इस तरह के जो circuit which I have drawn here is known as power on reset. This is known as power on reset circuit. Yes. So why I'm saying is that it is power on reset is because when you turn on your circuitry, so automatically pin number 9 जो है ये through this capacitor is connected to the VCC, ठीक है? और कुछ देर के बाद ये कैपेसिटर जो चार्ज हो जाएगा, when it becomes fully charged, then this VCC is connected to pin number 9. So this kind of circuit is known as power on reset. And this is a current limiting resistor 8.2K. But normally this kind of circuit is not used जब हम actual कोई ऑपरेशन एक्चुअल अगर हम प्रोजेक्ट बनाते हैं, बिकॉज इन दिस केस whenever you want to give it a reset, you have to again turn it off and again turn it on, है ना? पावर ऑन मीन्स इट विल बी टर्न ऑन व्हेन इट इज, पावर को टर्न ऑन करेंगे तो उससे क्या होगा कि जो इसके बाकी के ऑपरेशंस हैं दे आर आल्सो अफेक्टेड. सो इफ वी डोंट वांट दैट टू हैपन, व्हाट वी कैन डू इज वी कैन सिंपली बाईपास दिस कैपेसिटर विद अ स्विच. what we do is that whenever we want to give it a reset, we simply press this switch for a few machine cycles. So automatically वो क्या होगा, जब ये circuit इससे complete हो जाएगा, we will be giving it VCC and then it will be reset. So उससे क्या होगा कि you don't have to affect the operation of the other registers. Simply आपको अगर पिन नंबर 9 पे reset देना है तो आप ये debounce switch को on कीजिए, तो इसको बोलते हैं हम debounce, recent debounce with reset with debounce का मतलब है ये key के साथ. So this is basically normally the circuit which is used for the reset. So after we give it a reset, the status of the registers become this. This is the reset value of some of the registers. The program counter becomes 0, accumulator becomes 0, B becomes 0, PSW program status word becomes 0. Then your stack pointer की वैल्यू जो है वो 0007 है. ये आप लोग याद रखना, बिकॉज इतना डिटेल तो मैं अभी यहाँ पे नहीं बता नहीं पाऊंगी, बट व्हेन विल बी डूइंग इन अ रेगुलर क्लास देन आई विल टेल यू व्हाई द वैल्यू ऑफ स्टैक पॉइंटर इज 0. सो जस्ट रिमेंबर दिस थिंग. एंड देन DPTR वैल्यू इज अगेन 0. Now, see this circuit. This is the circuit which is the basic circuit which you have to make for any application. आप कोई भी प्रोजेक्ट बना रहे हैं, आपको इनिशियली इतने कनेक्शंस तो करने ही करने पड़ेंगे. कौन कौन से? There are 3 main things which you have to remember. One is pin number 9, reset circuitry. ये कनेक्शंस आपको इस तरह के 110 माइक्रोफेरेड का 110 माइक्रोफेरेड का कैपेसिटर, देन 8.2K का करंट लिमिटिंग रेजिस्टर, 1 debounce switch, pin number 18 and 19. As you can see, we connected one 11.0592 megahertz crystal and two 33 picofarads or 30 or 22 picofarad capacitors. और इसमें कुछ आप देख रहे हैं? One more thing I have connected. Yes, can you see this circuit? Can you see this circuit, participants?
Yes, ma'am.
So see, basically we have 3 connections.
Yes, ma'am.
कौन कौन से? एक तो हमारा रीसेट सर्किटरी हो गया, दूसरा हो गया हमारा
दूसरा ग्राउंड.
Actually this circuit I'm talking about. Yes, in this circuit just see, one I have connected is on pin number 9 the reset circuit, the another is on pin number 18 and 19 I have connected a quartz crystal, that is your oscillator circuit. There is one more thing I have connected, can you please tell me?
It is VPP. क्या होगा?
Yes, you are right. Pin number 31.
Number 31. Yes, ma'am.
Yeah, that is external access, EA.
Yes, ma'am.
So this is what I was telling you at that time. Remember when I told you about external RAM interfacing or ROM interfacing, I told you that pin number 31 is very important. It cannot be left unconnected. So this circuitry means, ये जो मैंने connection किया है, I have connected it to VCC. That means, am I doing external RAM interfacing or not? No. When EA is connected to ground, that means I have externally connected a memory. But in this case, I have connected it to VCC. That means I have not connected any external memory to it. So this is a basic microcontroller circuit which all of you must design initially. उसके बाद फिर आपने जो अपनी इंटरफेसिंग करनी है उसके हिसाब से आप जो है वो इसमें कनेक्शंस करेंगे. ठीक है?
ये जो आपने बताया 11.4